La Grama is an industrial company producing home furniture located in Vinaròs, Spain, which mainly sells in Spain but is beginning to export to other countries such as Italy or the United States. It has specialised in custom furniture and the manufacture of lot size 1, offering a wide variety of models and colours, making each piece of furniture a unique piece for the consumer. The changes in the market demands require a higher level of customisation, what leads to major change in the production flow. For La Grama, the supply network of products that are not manufactured inside the company is defined from scratch for each customer order. La Grama becomes a lot size 1 consolidation centre, establishing an agile network of collaborators through EFPF solutions. The predictive maintenance scenario is focused on the monitoring of the operation of an edge banding machine to detect anomalous working conditions and take preventative actions through machine data analysis. The role of edema in the development of the predictive maintenance scenario of the EFPF furniture pilot has been the validation of the devices, such as sensors and systems, and the construction of an electrical cabinet in the edema facilities, before transferring everything to the industrial environment in La Grama. Close contact with La Grama technicians and technical developers has been maintained, providing continuous feedback on detected errors, doubts, and performing testing activities. The machine sensors are connected to an interface board on a factory connector, which monitors the values and publishes them to the EFPF data broker. The analytics component monitors this data and builds up a machine learning model. The analytics components are able to evaluate if there is a risk of a machine breakdown, and in such case triggers an alert to the maintenance staff in La Grama. An evaluation rig was defined and deployed as a first approach before addressing the definitive installation at the La Grama premises. The required hardware components were assembled in edema for preliminary testing. Once the rig was prepared, this was transferred to La Grama connectivity tests and then moved back to edema in order to complete the configuration and install the rig components in an electrical cabinet. A list of all the required hardware to build the electrical cabinet was elaborated. The electricians first prepared the electrical board to make it ready for power supply and connectivity to machine sensors. The electrical cabinet was then tested in the edema premises, checking the connectivity of the factory connector, the analog cards, the power supply, and the overall function of the electric panel installation. Just some adjustments were required to get the cabinet ready for deployment. Once the cabinet was prepared and tested for further connectivity sessions in La Grama were arranged. The cabinet was placed next to the edge banding machine and the sensors were attached to the corresponding connections of the cabinet. The real-time data monitoring in the edge banding machine was finally achieved, publishing sensor data every 10 seconds. Data from sensors was successfully retrieved and published in the message broker, enabling the experimentation with the analytics tools. The analysis of machine data is covered by 3 different tools. The anomaly detection service supports the technicians to detect problems and upsets during the production process. The service uses machine learning algorithms that need to be trained with data coming from the machine at specific conditions. The solution provides historic data and real-time data prompting information about anomalies if detected. The risk opportunity analysis and monitoring solution is used to manage the sending of warning emails. The tool processes data streams into metrics, providing a visualization that enables getting insights about costs, risks, and opportunities. The tool manages recipes that can be customized for the specific furniture manufacturing in the environment of La Grama. Finally, the deep learning toolkit is used to predict machine failures, taking the machine sensor data. The tool labels the machine data as right or wrong depending on thresholds and then processed by a neural network for training. Users can inspect live data about temperature, current, and pressure, providing a real-time prediction about the behaviour of the machine in a short term. The predictive maintenance solution enables La Grama to monitor machinery production, detect any anomalous machinery conditions, prevent some possible failures, and take preventative actions.